Hello and welcome to Avaz Tech Lab. Today we will be looking into how to automate and secure our deployment workflow. So here we will be trying to create a three-tier CI/CD pipeline using Jenkins, SonarQube, Trivy, Docker, and Amazon EKS. So if you have a look into the diagram, we have three types of deployment. First is local deployment. In the local deployment, the initial development and testing happens. And here the app is connected to essential services like EC2 instances, Cloudinary, MongoDB, and Mapbox. Here, developer should be able to test the application in their local environment before they inform DevOps team to create the pipeline because they need to test if the application is working fine or not. So the first thing that developer they are going to do is to build the application in their local laptop or local machine. For that, they are going to first download the dependencies using the Node.js and npm to deploy the application in the local environment. And they can check once that is done, then they are going to inform DevOps team that they can proceed with the creation of pipeline to deploy the application to lower environment like dev deployment, or we can say dev environment. Then we are going to create the Jenkins pipelines, like write the pipeline to install the application dependencies. So in the CI/CD pipeline, the Jenkins integration first start with testing stage. So here Jenkins runs unit test to verify that recent changes don't break existing functionalities. Then we have a SonarQube that scans the codebase to enforce coding standards, check for code smell, and identify potential bugs. Then we have Trivy FS Scan. The pipeline integrates Trivy FS Scan to examine the file system for any vulnerabilities. Then we have a Docker. A Docker image is built with the latest code and dependencies, creating a standardized environment for testing and production. Then we have a Trivy Image Scan. After building the image, Trivy performs another scan specifically on the Docker image, detecting any vulnerabilities in dependencies and base image. Then we have a Docker push. So once scan pass, the Docker image is pushed to a container registry. It can be a Docker hub and making it available for deployment. So finally the app is deployed in a development container environment for integration testing and validation. And in the part 2, we will be looking into the production deployment. So in the production deployment, it will be a deployment to Amazon EKS. So once the application successfully passes all stages, it is ready for production deployment hosted on Amazon Elastic Kubernetes services. So in the EKS deployment, the containerized application is deployed to Amazon EKS, a managed Kubernetes service that ensures scalability, high availability, and managed resources. Continuous monitoring and alerting. So in production, continuous monitoring is implemented to track performance, resource utilization, and application health. Real-time alerts notify about any anomalies, ensuring rapid response to potential issues. So let's start with the local deployment first. So this is the application, and we can create a CI/CD pipeline. This is a three-tier architecture project for Node.js app, and here I will be going to show you how we can integrate with database also. So here in this application, we can click on register and we can register ourselves. Here we can enter our username, some email and password. So before creating the virtual machine, let's see which all ports we are going to open. So these are my inbound rules which you have to create, like HTTP, HTTPS, SSH. So these are the ports open for HTTP. Then we have for MongoDB. Then next is SSH, HTTPS port 443, custom TCP port which is in the range of 3000 to 10,000. Then we have custom TCP for use for Kubernetes API server or similar services for port 6443. Then SMTP, which is in the port 25, and SMTPS for port 465. So the key point here is port 80, which is HTTP, then port 443, which is HTTPS, and port 25, which is for SMTP. So these are commonly open for web traffic and email services. Then we have port 22. SSH is usually restricted to specific IPs to prevent unauthorized remote access. Then we have port 6443, which could be related to Kubernetes management. Then we have port 465 for SMTP and port 27017 for MongoDB. So let's start with creating the first instance. The name, I will put it local. Select the tab Ubuntu, and here we will be selecting the AMI type, which is of Ubuntu Server 22.04 LTS. Select the instance type T2 medium. Keep here the key pair which I had created. Go to the network settings, edit, auto assign public IP enable. Then we will select the existing security group. We have DevOps SG. Storage we will make it 20 and click on launch instance. So let's copy the instance public IP and connect to the machine. Clear the screen. So let's create a directory. Go to the directory, and the first command we will run sudo apt update. So this command basically is used on Ubuntu Linux distribution to update the packages index on your system. Lists from the repositories to ensure you have the most recent information about available updates and software versions. Then next we will install Node.js. For this we will run this curl command, and then we will export this particular command. Next is to install nvm 21. So run this command. Then we will check the node version, node-b, and npm version, npm-b. So the next step is to create an account in Cloudinary. So in the Google search, just type Cloudinary login, click on this, click on login. Then we can sign in using the Google account. So Once you are logged in, then click on the view API's keys. Then we can copy the API key and API secret and keep it safe in some place. Next is to create an account in the Mapbox. Here you need to click on Mapbox sign in. And here it will ask you to enter your credit or debit card details. So it's up to you whether you want to enter the details or not. I am opting not to enter because I am not going into the functionality of Mapbox here. So I will be just demonstrating how CICD basically works. Next, we have to create a cloud database. For that, in the Google search, just type Mongo Atlas and click on the first link, official site. And you can click on sign up with Google. So it will take you to the page where you can see the clusters and database service. And you can create cluster by clicking on plus create button. You need to just click on the free version and create the database. So I have already created the database. So click on the browse collections. Go to the tests, and here will be your details of users and session will be stored. Now in the database services, you need to go to the connect option of your database, and here click on the first option, connect to your application, that is the driver. And here you can see the connection string which is mentioned here. So you need to copy this connection string, and I will tell you where basically we need to paste it. In order to create the database user, you need to go to the database access section in the left hand side and click on that, and you can create add new database user. So it will ask for the username and password, and you can create the database. So I already have the database created, so I'm not going to create a new database user. I will be using the credentials of this database user in the application. Now we can connect to our local instance which we had created. Copy the IP address from here, public IP address, go to your command line prompt and paste SHS command. So it is connected now. Now go to the DevOps folder, and here we will copy our code. For that, go to the GitHub repository, copy the GitHub repo link from here and paste it here. Go to the DevOps CICD folder, type ls here. Now the first command I'm going to run is the npm install. So this command basically is used to install the dependencies for the Node.js project defined in the package.json file. Clear the screen, and we will open next file is the environment variable.env. So here, as you can see, we have all the variables defined here. So the last time which we copied the keys and secrets, so we will paste it here. So our Cloudinary cloud name will be this one, which we have copied from the Cloudinary portal, and this is the key and secret. And Mapbox token, so this is just a random token which I have taken it from the internet. We are not going to show the functionality of the Mapbox, but here just to make our application running, we will be using some random Mapbox token which is available in the internet. And this is the database URL, MongoDB cloud database. So this is the connection string which we copied last time, so we will paste it here. And the secret will be any random secret, you can keep it here. So it can be anything, so I have kept it here, DevOps. Now come out from this file, and the next command you have to run is npm start. So this command is basically used to run a script in the package.json file for the Node.js project. So as you can see clearly here, the database, it is showing it is connected here. Now copy the public IP address of the local instance and go to the browser and type the IP address colon 3000. So as you can see, our application is up and running, and we can click on the register button, or we can type some username and random email, and password. So as you can see, the application is working perfectly fine. There is no error, and we are able to log in successfully. Now, in order to see the data is created in our database or not, we have to go to the cloud.mongodb.com and click on the database services. Go to the browse collections, click on test users. So as you can see here, this is the data which we created just now. So our application is working perfectly now. Now we are going to create a deployment in a dev environment. So for that, launch an instance. So we are going to create one instance for the dev environment, that is, we will keep a name Jenkins. Select Ubuntu. Select Ubuntu Server 22.04. And here the instance type should be, we are going to select titulars because we are going to build our application in the Jenkins master itself. And in the key pair, we can select DevOps. In the network setting, we can select existing group. From here, we can select DevOps SG, which we created the security group earlier. And in the storage section, we can put 20 GB. Now click on launch instance. Next, we can create an instance for the SonarQube. So click on launch instance. Type the name SonarQube. Again, select Ubuntu. And AMI Ubuntu Server 22.04 LTS. And the instance type. So in this one, we are going to keep T2 medium. Keep a login, the existing one, DevOps. If you don't have the existing DevOps or any key pair, then you can create from here. And in the network settings, we can select existing security group. So we have the existing security group DevOps SG, and storage type, we can keep it 15. Click on launch instance. So all the three instances, local, SonarQube, and Jenkins, are running for us. Now we already have local instance running, so we will be connecting to rest of the two instances, Jenkins and SonarQube. And for that, we will be creating two separate command prompt, and we are going to connect to the instance here. So copy the Jenkins public IP address from here, go to the command prompt and paste SSH command. Press yes. And we are connected here. In the same way, copy the public IP address of SonarQube, go to the next terminal and create an SSH command and connect here. Type yes, and we are connected to the SonarQube instance. So this is the SonarQube instance. This one is our Jenkins instance. and this is the first one, which is the local instance. So now we are in the Jenkins instance. The very first command we are going to run is sudo apt update. So the command sudo apt update is used on Ubuntu. It is used to update the package index on your system. It retrieves the latest package list from the repositories to ensure that you have the most recent information about available updates and software version. Next is to install Java in your local machine. So type Java. As you can see, Java is not installed here, so we can copy this particular command, paste it here, append -y, and this will install Java on your machine. So now clear the screen. Next, we have to install the Jenkins. So for that, go to this particular Jenkins website, and from in the long-term support section, copy this particular command. Go back to your terminal. Here first, we will create a folder named script, mkdir. Go inside the script folder, and here we will be creating a file vigen.sh. Paste the command here and append -y. Save the file, and before running this file, we need to make it executable. So just type this command, type ls. As you can see, our file is executable now. Now to install the Jenkins, just run this particular file. So as you can see, we don't have any error. So Jenkins is successfully installed in our Jenkins server. Now copy the public IP of Jenkins, and in the URL just type IP address port 8080. As you can see, this page has appeared and it shows that the Jenkins is successfully installed in our server. Clear the screen now. Now next we have to install the Docker. So for that, just type Docker, and as you can see, we have the command sudo apt install docker.io. Copy this, paste it here, append -y, so that we should not get any prompt, and it is installing the Docker in our machine. So as you can see, the Docker is successfully installed. Now we will start configuring the Jenkins. So copy this file location from here and go back to the Jenkins server terminal. Clear it, type sudo cat, and this, paste it here, and this is the code which we have got. Copy it from here, go back to the Jenkins, and here we'll paste the password. Continue. Now it is going to install our Jenkins, so select the install suggested plugin only, and our installation has started. Now we will try to run some Docker command here. So just type docker pull hello world. So as you can see, we are getting the permission denied error since the user doesn't have permission. It shows that Ubuntu user cannot execute this particular command. So we are going to give the permission here. Run this command. Now we can again try this particular command, and as you can see, now the permission has been given. Now we will go to the SonarQube server, and the very first command here we have to run is sudo apt update. Next, clear the screen, install Docker, copy this command and append -y. So Docker is installed successfully now. So once the Docker is installed, we will give permission to the Ubuntu user to execute the Docker command. So run this command. So here the Docker run, this command is used to start a new container, and -d flag. So this flag tells Docker to run the command in detached mode, that is basically in the background, and -name. So this assigns the name Sonar to the container, and -v 9000 colon 9000. So this maps port 9000 on the host machine to port 9000 inside the container. So SonarQube typically runs on port 9000 by default, and we have at the last SonarQube colon LTS community. So this basically specifies the image to use, and in this case it is LTS community version of the SonarQube image from the Docker Hub. So what basically happens here? So Docker will download the SonarQube LTS community edition image, and it will then start a container named Sonar running SonarQube. So once this is done, we can access the SonarQube by navigating to the IP address of the instance and colon 9000 in our web browser. So copy the public IP address of the SonarQube, go to the browser and type IP address 9000. Okay, I think we are unable to connect. We have not executed the command. So execute the command here. So let's wait for this to complete. Okay, so this is complete now. Go back to the browser and once again refresh. So it is loading now. Oh, we can enter the credential here. So it is admin. Type enter. It will ask to change the password. So admin is the old password. We can keep the new password. Okay, now go back to the Jenkins. So here we can create any user password. We can confirm the password, any email, and save and continue. So here, as you can see in our SonarQube, we got the dashboard, and back to the Jenkins, it is configuring. So this is the Jenkins URL. Click on save and finish and start using the Jenkins. So our Jenkins is also up, and along with this we have SonarQube also up. Now we are going to install certain plugins in the Jenkins. So go to the manage Jenkins, then plugin, available plugins, type here Node.js. Next is SonarQube scanner, select the SonarQube scanner. Next Docker, select the Docker and Docker pipeline. Next is Kubernetes, so select the Kubernetes and Kubernetes CLI. So that's all. Now we can click on install, so it will install all these plugins. So all the plugins are installed now. Now, since Trivy plugin is not available in the Jenkins, so what we are going to do, we will be installing Trivy manually in the Jenkins server. So for that, you have to go to this particular portal, trivy.dev, and in this we have to go to the section debian/ubuntu, and we can copy this command. Now go back to the terminal and we can go to the script folder, and here we can create a file tri.sh. paste the commands here, and at last append -y, save the file, make it executable. As you can see, now it is executable, and run this command. Type yes. So as you can see, Trivy plugin is installed successfully. Now go back to the Jenkins. So here, we have to configure all these plugins. So for that, you have to go to the Manage Jenkins, Tools, search for SonarQube installation. So this is the SonarQube installation. Add SonarQube scanner. So just type here name Sonar Scanner. The SonarQube scanner, the version. So I'm going to use the latest one here. Now we have to go to Node.js installation. So type here Node.js installation, add Node.js, and type here Node 21. And select the version Node 21.7.0. Next, go to the Docker installation, add Docker, type the name Docker, install automatically, and from here select download from docker.com, and the Docker version is the latest. Now click on apply. So all the tools we have configured here. So now the next step is we have to configure the SonarQube server inside the Jenkins. So for that we have to go to administration, security, user, tokens, and enter the token name A. We can generate, and we can copy this token. Click on done. Now go back to the Jenkins, manage Jenkins. Here choose credentials, global, and add credentials. Kind should be secret text, and paste the secret here, and type the ID Sonar token, and description should also be a Sonar token, and create. Now we will start creating a pipeline. Go to the dashboard, create a job, enter the job name. So dev env, select pipeline, click on OK. So click on the discard old build. So the maximum number of build what we will keep is 2. Apply. Go to the pipeline, and in the pipeline script paste this command. So don't worry, these commands and all the steps will be shared with you all. So we'll start with the first, the pipeline. So this is basically the Jenkins pipeline script. It is a declarative pipeline that automates the CICD process for a Node.js based full stack application. And here I have mentioned agent any. So this the pipeline can run on any available Jenkins agent, and the Node.js tool is Node 21. So it basically specifies that Node.js version 21 should be used, and the SonarQube scanner. So here I have set up the SonarQube scanner tool for code analysis. Next is the Git checkout. So here I am cloning the repository from GitHub, and this will be checking out the main branch. So this is my GitHub repository. So this you can get it from this particular link. Now coming back to the install package dependencies. So this basically installs required Node.js dependencies from the package.json. Then we have to run the unit test. So this basically executes unit test using the npm test command. Then we have Trivy FS Scan. So here I am running Trivy security scan on the local file system to identify any vulnerabilities, and it will basically output the scan report in fs-report.html. Then we have SonarQube code analysis. So here it basically runs static code analysis using SonarQube, and here the project key is project name is campground. Then next we have a Docker build and tag. So it builds a Docker image from the project directory and it tags it as like this. And it uses store Docker credential, Docker crate here. So I have mentioned here Docker crate. Then next we have Trivy Image Scan. So here it scans the built Docker image for any vulnerabilities using Trivy, and it saves the report on FS report, fs-report.html. And the next is the Docker push image. So it pushes the Docker image to the Docker registry. Here, for example, the Docker hub. The last one is the Docker deploy to local. So it basically runs the container locally, mapping the port 3000. So the pipeline follows a structured CICD workflow. It pulls code from GitHub, install dependencies, and run unit tests, scan the vulnerabilities, and perform static code analysis, build and push a Docker image, and deploys the container locally. Now click on apply, and we will try to run this one. Build now. So as you can see, build is success now. Now copy the IP address of the Jenkins server. So as you can see, I'm copying the IP address of Jenkins is 13.216.168.120. So as you can see, our application is up and running. We can try to register here. So we can try to register. Give the email address, some random password, and click on register. So as you can see, we are able to log in. So our application is running now. Now we can go to the SonarQube dashboard, click on the project, go to the overall code. So we can see here getting all the details. So we have as of now 1 bug, 16 security hotspots, and all these details. So that's all about this session. So we have done the local deployment, and we have demonstrated the CI/CD pipeline, and we created the development environment. Now in the part 2, we will be trying to deploy our application in the production environment, and it will be deployed in the Amazon EKS cluster. So that's all for today. Thank you.